So our first rule that we're going to introduce, or I should say reintroduce today, is what we call corresponding angles. So hopefully hearing that name rings a bell. If not, remember, we're going to get a lot of practice with this before we move on. For every single rule that we're talking about today, we're going to use the same diagram, just highlighting different angles. So here are a couple of parallel lines. I've got a transversal cutting through. And I'll go ahead and highlight a couple of these. We're going to have angle A right here. And we're going to have angle B right here. The good thing is that all of these angle relationships today are either going to be congruent or supplementary. We don't have any oddball ones today, though we'll introduce a few more of those on Monday. So looking at these angles, logically, if you know that they are either congruent or supplementary, logically you should be able to look at these and determine which one what they are. So what do you think? Are these supplementary or congruent angles?
Supplementary.
Congruent. So think about this. This angle A, is it acute or obtuse?
Oh, it's obtuse.
It's obtuse. It's greater than 90 degrees. This angle, what is it? Same thing. It's obtuse. If you have more than 90 degrees and more than 90 degrees and you add those together, it's going to be more than 180 degrees. So my whole point in saying this is that as you keep moving forward, we're going to see a lot of angle relationships. And like I said, they're all going to be congruent or supplementary. If they are both acute or they are both obtuse, that means they're congruent to each other. If you've got one acute, one obtuse, well, they obviously can't be congruent. And in that case, they're going to match together perfectly and become supplementary. So it's a really kind of straightforward relationship as far as the angles go. So even if you forget what they're called, just visually inspecting the angles should tell you if they're congruent or supplementary. You guys with me on that idea? Okay, so I hope that's something you can come back to. I see mistakes with this stuff every year, and I'm hoping you guys can kind of start internalizing all this stuff as fast as possible so that there are fewer mistakes. So we said these are congruent to each other. So the measure of angle A is going to equal the measure of angle B. And anytime these are equal, we're going to highlight that in yellow. I'll go ahead and start writing the description while you guys are getting your highlighting done. So corresponding angles correspond in their position. I should put in their relative position. And I'll explain what I mean by this. And we'll add a little bit more to this in just a minute, but I'll let you copy that down first. All right, so what this description means, when it says that corresponding angles correspond in their relative position, look at the examples we pointed out. I should mention right now that there are multiple pairs of corresponding angles in this diagram. I just picked these, and we'll make sense of this. A is at the bottom right at its intersection, right? Well, B is at the bottom right of its intersection. So the corresponding position is that they're both to the bottom right of their intersections. So that's what we mean when we say they correspond in their relative position. Here, bottom right, but we could have done the top left, the bottom left, the top right. So there are 4 sets of corresponding angles there. And so I'm going to add this little extra note right here that says, in our case, for example, we've got the bottom right. Okay, our abbreviation for this is going to be corresponding angles, written like that. The abbreviation should be short, but it should also be clear enough that there's no confusion over what you meant. So that's why we write it out like that. Okay, next one should be refresher again. And what we call this, luckily the names of these start telling us all that we need to know. Even corresponding angles tells us everything we need to know because we saw what corresponding is referring to here. But here we've got what are called same side interior angles. I'll draw the diagram for that. And the angles we're going to highlight in this one are going to be these two right here. I'm going to call this one angle A. Call this one right here angle B. So going back to our visual check, just a really basic visual check of these two angles, would you say these two angles are probably congruent or supplementary? Okay, supplementary. I can see right here that A is acute, B is obtuse, so there's no way they are congruent to each other. But if one's acute, one's obtuse, they could add up to 180, and that's what happens here. That is the case. So we're going to go ahead and add that little bit in. The measure of angle A plus the measure of angle B equals 180. And the color we use for showing supplementary or summing up to 180 relationships is pink. There it is. It's worth the reminder to say that I'm highlighting these equations right here because we are forced to use these equations when we've identified its same side interior. The name here says everything. Same side, what does same side mean? Same side of? The line, what do we call that line? The transversal. It's the same side of the transversal. In this case, they're both on the left side of the transversal. Interior means they're inside the parallel lines. So, the name tells us everything, and once we've identified that relationship, we are forced to use that equation, that those two angles add up to 180. I'll start writing the description of this. All right, so we'll say that, there it is. Okay, same side interior angles are on the same side of the transversal and on the interior of the parallel lines. All right, so I'll underline those important ideas right there and add on there the abbreviation we're going to use. Now I'll give you some time to write that down before we move on. All right, so the kind of corollary or flip side to the same side interior angles, once I say the name of this, you're going to probably have a really good idea of what this is all going to be about. This is same side exterior angles. So I bet I could stop right here and you guys would know what to do, but I'll continue. So same side exterior angles. Again, your diagram, that's going to be the same, parallel lines. But now, I'm going to highlight this angle right here and this angle right here. Yeah. You go ahead, I'll sign it. All right, so hopefully the name and the diagram are matching up in your mind. Same side, they're still on the left side of the transversal. I could have made it the right side. As long as they're on the same side of the transversal, that's what matters. And this case, they're on the exterior of the parallel lines. They're both outside the parallel lines. So that's why they're same side exterior. And does our equation change for this? No, it's still going to be supplementary. So I still have measure of angle A plus the measure of angle B equals the 180. If I can think straight. All right, and those are going to be highlighted in pink because it's still a supplementary relationship. What I'm going to do is go ahead and write out the description. Our abbreviation, what do you think it's going to be? SSE. So our description is going to be a little shorter this time. It's going to be the same as above, but on the exterior of the parallel lines. Okay, the next one we're going to introduce is definitely, of these five, the most frequently used, and it's one that you should remember to some degree. It's what we call alternate interior angles. They are sometimes called opposite interior angles, but that's not how we're going to refer to them. And most places will refer to these as alternate interior angles.
Is it the same diagram?
Yeah, same basic diagram. Because all of these angle relationships are dealing with transversals cutting through parallel lines. So we can start off the same way. And now we get these two angles right here. So a quick check, a visual inspection of these, even if we forget the name of them, but a quick check of this is going to tell us that these are what? Congruent or supplementary? Congruent. They're both acute angles. There's no way they add up to 180, but they're both acute, so they could be congruent. So that's the case here. Measure of angle A equals the measure of angle B. And now we will highlight that in yellow. In fact, I'm going to add a star next to this one just to show of these five, this is the one that appears the most frequently, especially later when we get to triangle congruence proofs. These alternate interiors will show up in the vast majority of the proofs. So the description here, alternate interior angles. are on opposite sides of the transversal. Which is why they're sometimes called opposite interior. But they're on opposite sides of the transversal. And on the interior of the parallel lines. And in the interior, however you want to say that. I'll go ahead and put our abbreviation for this one is going to be AIA. So one thing, because this is so common, one thing I want you guys to kind of keep in mind with the alternate interior angles is that you're looking for a Z shape in your diagram. So if you kind of eliminate all the other lines from that diagram, you can kind of distill it down to this shape right here with those angles marked, right? Now your Z might be really weird shaped. It's possible that it could look like this. I guess that's still kind of Z-shaped. But kind of that Z shape is what you're looking for in order to determine, are these alternate interior angles? If you see the Z, yes, they are. Okay, so that's the single most important one to really memorize. And luckily, in past years, students have gotten to be really good at identifying alternate interior angles. The corresponding angles, I'll tell you, are ones that students really struggle with. All right, and same side interior, that's where students struggle remembering that those are supplementary, not congruent. So just look, do the visual check. The last one won't take us very long. It's probably not going to come as a shock. These are alternate exterior angles. These don't show up nearly as often as alternate interior, but they will show up. In the past, I used to not even give this one as a rule, and we would just talk about the alternate interior, same side interior, and corresponding, but it's worth having these as a separate rule, just because they will show up from time to time. All right, so maybe we can use this one right here is going to be angle A, and this one right here will be angle B. So are these congruent or supplementary? Congruent. So if it's alternate, and again, the alternate means on different sides of the transversal. If it's alternate interior, alternate exterior, it's going to be the same basic angle relationship. So the measure of angle A will equal the measure of angle B. So I'll still highlight that in yellow. We just have to make sure we identify it with the correct name. All right, our description here will be kind of short. Same as above, but on the exterior of the parallel lines. And of course, our abbreviation here, you could probably guess, would be AEA.